Good morning, Bukit, to our honorable judges. We are doing this solar still in the topic of chemistry. We are from SMK Bukit Jambul. Our team is called the A team. Now, after finish assembling most of our model, we will be covering the copper tubing with a thick layer of fine granular. After covering the copper tubing in fine granular, we can now measure the temperature of the granular. The result is around 67.6 Celsius.
Next, we will also be putting the fine granular inside the containment A, which is a black tin. The results will be a black tin filled with fine granular. The use of the fine granular is formed by several types of metal as a solar thermal collector. The fine granular consists of iron and aluminium as a thermal insulation and collector. Aluminium, which is the second highest in thermal conductivity but the highest specific heat capacity, allows the thermal heat to distribute more evenly. Iron, which has a lower specific heat capacity but its density compensation, its deficiency making it the best thermal storage agent.
Now, we will be moving on to the microcontroller and sensor. We will be installing the microcontroller and sensor next to the copper tubes. Now, we can put 500 ml of water into the small tin to start the process. In containment B, we will be putting salt on ice that is submerged in water to decrease the temperature of ice. Then, we can measure the container that contains the ice to check the temperature. And the result we got is negative 25.8 Celsius.
Next, we will be opening the vacuum pump. Lower pressure means there's less force pushing down on the water molecules. This makes it easier for them to break free from the liquid surface and enter the air as vapor. This is the evaporation process under low pressure. When the pressure is high, the air can hold more moisture. This means that the water vapor is more likely to condense back into liquid form.
Based on the microcontroller, we can see that the temperature of the copper tubing is high, which means we can now start allowing the water through the tubes.
After a long process, we collected some distilled water in the glass bottle. Now is the time to retrieve the water. First, we can close the valves and take the vacuum pump. After that, we can take out the pipes to retrieve the water. After cleaning the top of the bottle, we can now pour out the water into a small measuring cylinder. This is to measure the volume of water that is collected by our project.
And now for the final test, we are going to test the pH of the water. The pH of the water is 7, which makes it neutral.
Solar still innovation. First off, we have the use of low pressure. The use of low pressure is separated into two ways. 1. Evaporation. 2. Condensation. Less force pushing down on the water molecules. This makes the water molecules easier for them to break free from the liquid surface and enter air as water vapor. Then, the water vapor is transferred through a copper tube for condensation process. The air can hold less moisture, meaning the water vapor is likely to condense back to liquid form. And now, the evaporation process under low pressure used in our project. The water in the bottle evaporates due to the fine granular in a tin can painted in black, which is also known as containment A. Next, why did we use copper tubing? We decided to use copper tubing as the carrier due to its high thermal conductivity and cover it with fine granular. which consists of iron and aluminium. As thermal insulation and collector, our design focus on better thermal collector, carrier, and transfer by also using conductive method instead of just convection and radiance. And now, the secret of ice and salt. The power of ice added with salt. Salt is added into the ice, which will melt the ice and turns it into water. Then the temperature of the water will decrease due to the added salt. And now, finally, the use of fine granular. As I said before, iron and aluminium is used as a thermal insulation and heat collector. Aluminium is second highest in thermal conductivity and the highest specific heat capacity. Although iron has a lower specific heat capacity, is the highest for density compensation.
That is all from us. Thank you.